Namaskara. After having done some problems on DC circuits, we will go for some more. Before I go for the problems, I will tell how to solve my simultaneous equations using the calculator. As such, simultaneous equations can be solved by substitution method or elimination method or determinant method. However, based on this, calculator will help you to solve the simultaneous equations quite easily. In that respect, you have come across two different type of calculators that are generally used by the students. One is M991MS and the other one is 991ES. 991 FX991 is this one, and the other one is this. To solve this one, consider the two simultaneous equation 7I1 minus 5I2 equal to minus 10, that is equation 1, and minus 5I1 plus 9I2 equal to minus 20, that is the second equation. In order to solve this one, now in respect of Fx991MS, say after you switch on the calculator, go to mode, press 3 times till you get the equations mat VCT on the screen. That is what I have written here. If you press 1, it takes you to a screen displaying unknowns 2 and 3. 2 represents two simultaneous equation, 3 for 3 simultaneous equation. At the same time, you see an arrow here. The arrow is to solve or to go for the 2 degree or third degree equations that you can see here, degrees. It gives you 2 or 3 like that. And then since it's a two simultaneous equation, press 2, it leads to A1 equal to 0, A1, and the display is here is 0. Now what is this A1? Coefficient of I1 is taken as A1, coefficient of I2 is taken as B1, coefficient of 10 is taken as C1. Similarly, this is A2, B2 and C2. Now to get the solution, now once you come across a display of A1, enter A1 is equal to 7. So in that respect, here you can see I press 7, then equal to, it displays B1, B1 being minus 5 equal to, then C1 is minus 10 equal to, it asks for A2, A2 is nothing but minus 5 equal to, it calls for B2, B2 is 9 equal to, and then C2 is minus 20, that is this, equal to, will display value of X is equal to minus 5. Here X is nothing but equal to, this itself is I1. Again pressing equal to will lead to Y is equal to minus 5, and that is nothing but I2. Incidentally, here I1 and I2 are of same value, but anyhow, by using this or by adopting this method, by using the calculator, it is possible to get the simultaneous solution of the simultaneous equation very easily. Then if you go for the other, this is Fx991ES, press on and go to mode. When you go to mode, it displays 1 computation, 2 complex, 3 statistics like that. If you look at that one, 5 equation, it gives you 5 equations. Press 5, it displays 1, 2, 3, 4. One is for a simultaneous equation of 2 simultaneous equation, then where 2 unknowns are there. 2 is for 3 simultaneous equations where there are 3 unknowns, and third one is for second degree equation, and fourth is third degree equation. Since it is two simultaneous equation, press 1, it leads to a display of this one. It's nothing but a matrix method. Press, say, A1 is equal to minus 7 equal to, it calls for, it doesn't call for any other value, but the display shifts to B. B is nothing but minus 5 equal to, then minus 10 equal to, then go for the other one, minus 5 equal to, 9 equal to, minus 20 equal to, will give you it is 7 equal to minus 5 minus 10 minus 5 x is minus 5 and again press y, that's press x equal to, again it gives you minus 5. So in this way we will work out, considering this way or solving the equations in this way, you can find out the values of the unknowns. And in that respect, consider an example. Find the current distribution in the network shown. This is the network given. This is 1 ampere, 1 ohm, 2 ohm, 3 ohm, 4 ohm, and this is 5 ohm. If the current is entering here, it's coming out here. It is required to find out the current in different parts. Say call it as say A, B. This can be taken as say O, and this one is taken as C. Can we go for the loop method? If I go for loop method here as well as here, no doubt the voltage equations results into 0 on the right hand side, but you will observe these details or this 1 ampere will not have been covered. In that respect, to solve this one, assume a current I here. Once you assume a current here, this must be 1 minus I. If this current comes here, I have taken this as, for convenience, I1. If this is I1, the current here is obviously I minus I1. What will be the current here now? It must obviously be at this point, this is the current here plus this. So the current here will be equal to 1 minus I1 will be the current. Yes, I1 will be the current. Once we know this one, now apply Kirchhoff law for this loop A, B, A, O. In that case, here as we move this way, minus 2I1, 2I. Here it is minus 3I1. Then as we come this way, it is plus 1 into 1 minus I equal to 0. Other equation, go for this. It can be simplified also. This will be minus 3I, then minus 3I1 equal to minus 1. Call this one as equation 1. When it goes to this one, it will be minus, go for this loop, BCAB. BCAB will be minus 4 into I minus I1, then plus, as we are going against the current, it has to be 1 minus I plus I1 into 5. Then again we are going or moving against this current, that will be plus 3 I1 is equal to 0, as there is no source here now. If it is say simplified, it works out to minus 9 I1 plus or minus 12 plus 12 I1 equal to, it is minus 5. This is equation 2. So once we get this, we can use a calculator where in which the coefficient of our coefficients are A1, B1 and C1. This is A2, B2 and C2. If you go for the calculator, the value of I comes to 0.428 amperes and I1 will be equal to minus 0.095 ampere. Once I get this, it is required to find out the branch currents. So what is this OB? IOB is obviously equal to, this is I equal to 0.428. When it comes to current here, it is IOA is equal to 1 minus 0.428 comes to 27.572 amperes. Coming to current here now, this I1, this is nothing but the current BA is equal to minus 0.095 ampere. The minus sign indicates that the current is not flowing from B to A, but it is from A to B. In that respect, you can write this one as IAB as equal to 0.095 ampere. The current in the branch BC, that's nothing but this one. It is I minus I1. I is being 0.428 minus I1 is nothing but minus 0.098 will give you some plus amperes. That will be 3.523 amperes. And finally, the current through, that's nothing but IAC will be equal to, that's this one, it is 1 minus 0.428 minus of plus is same as minus 0.095 will give the value. That's it. So that comes to 0.477. So thereby we can find out the currents in different branch. Here this also is an example of branch current method. Let's go for another problem. Two batteries A and B are joined in parallel. Connected across the battery terminals is a circuit consisting of a battery C in series with 25 ohm resistor, the negative terminal of C being connected to positive terminals of A and B. Battery A has an EMF of 108 volt and an internal resistance of 3 ohm, and corresponding values for battery B are 120 volt and 0.2 ohm. Battery C has an EMF of 30 volt and a negligible resistance. Determine the value and the direction of the current in each battery, the terminal voltage of battery A, state whether the batteries are discharging or getting charged. Here two batteries A and B, this is A and this is B, are joined in parallel. They are connected in parallel. Battery A has a voltage of, this is 108 volt and has an internal resistance of 3 ohm. The internal resistance can either be shown here or shown here. I will show it here. This is nothing but 3 ohm. Similarly, B has an voltage of 120 volt and there is a resistance of 2 ohm. This is connected to another battery. Battery C has an EMF of connected across the battery terminals is a circuit consisting of a battery C in series with 25 ohm resistor. So this is nothing but the C. this being 25 ohm. This is C. I will repeat. Connected across the battery terminals is a circuit consisting of a battery C with 25 ohm resistor. That is nothing but this one, where with the negative terminal of C being connected to positive terminals of A and B. So, what has been given here has been converted into a sketch. The statement has been converted into a sketch, and C has an internal or a voltage of 30 volts with an internal resistance of 0 ohm. Determine the value and direction of the current in each battery. So, in that respect, this cannot be simplified as it was done using the network reduction techniques, because we have the battery sources or batteries along with the resistors. The only way is to consider the loop equations. Consider the loop here, say I1, and another loop here I2. Call it as A, B. Since A and B are figuring here, I will call it as a P, Q, R, S, W, Y. For the loop, consider this loop, that is nothing but P, Q, R, Y, P. Start with this. Since the current flowing here, it is minus 3 I1. When it comes to here, minus to plus, that is nothing but plus 108. As I come here, plus to minus, it is minus 120. Then when I come to this resistance, there are two currents, I1 and I2. As far as I1 is concerned, it is minus 2 I1. And when it comes to I2, since I am going against the current, it has to be plus 2 I1. 2 I2 is equal to 0, having come back to the starting point. This can be written as equal to minus 5 I1 plus 2 I2 equal to minus 60. Call it as a 1. Go for this loop, in which case it can be written as equal to RSWYR. In this, there is no drop. As I come this way, minus to plus, it is plus 30. Then as the current flowing through this is I2, therefore it is 25 I2 minus, coming to this, 2 I2 plus, this is in the opposite direction, therefore it is 2 I1. Then I am going from minus to plus, therefore it has to be plus 120 equal to 0. This can be simplified as equal to 2 I1 minus 27 I2, and then it is minus 150. Call it as 2. Solve these two equations. So that comes to I1 will be equal to, this is minus 0.183 amps, and I2 will be equal to 5.54 amperes. Once we get this I1 and I2, determine the value and direction of current in each battery. In that respect, what is the direction of the current in this? As you can see here, I1 is minus, it is not in this direction, but it is in the opposite direction. Therefore, it is IQP is 0.183 amperes in A. When it comes to the current in this battery, if I take I1 as reference, the current through RY can be taken as equal to I1 minus I2. So this will be equal to, this is minus 0.183 minus 5.54. In the sense, now this works out to be 0.183, that will be 5.6723 amps with a negative sign, indicating that the current is not flowing is not in the direction of I1, but it is in the opposite direction. Opposite direction means it is nothing but equal to IYR. This will be equal to 5.723 amps. Then what will be the current in the battery? C. So that's nothing but equal to ISW equal to I2. I2 is nothing but 5.54 amps. So these are the currents in the battery. The terminal voltage of battery A. So what will be the voltage available at these 2 points? Is nothing but for that assume the voltage across this one is say some V. If at all I connect an voltmeter, it records the voltage, this voltage and the drop in this one. The current here is actually I1 is 0.183 minus, it is not in this direction but it is in the opposite direction, that is this way. With that in mind, now what will be the voltage here now? To understand that, apply Kirchhoff law for this loop. If I start from here plus to minus, that is nothing but minus 108. Then as the current is going this way, it is plus to minus, that is nothing but minus 3 into the current is nothing but 0.183. And if I take this one as minus and this is plus, it is minus to plus, it is nothing but plus V equal to 0. Therefore, you can find out what is the voltage V. That will be the terminal voltage. So that comes to, it is 108 minus of this minus 0.183 or plus 0.183, that comes to 100.55 volt. So with all these things, what has been the other data that has been asked to determine, state whether batteries are discharging or getting charged. As such, this I1 is flowing this way. Whenever the current is coming out of the positive terminal of the battery, it acts as a source. If the current enters at the positive terminal, it is getting charged. So with that in mind, you can see here now, this is the current being flowing from positive to this is getting charged. While here the current is in this direction, therefore this is also this is discharging, and here this is also discharging. These two are discharging while this is getting charged. That's the answer. B and C, they are discharging and the source A is getting charged. So that's this. Here I have gone one step ahead also to see that whether what has been worked out is right or wrong. Power supplied by B and C is equal to, it comes to 852.96, while power consumed by the circuit will be power consumed by these resistances plus power consumed by this also. So that works out to also 852.96, that indicates whatever that has been worked out is correct. The same thing will also be, I will just illustrate the similar aspect in another problem. For the circuit shown in the figure, find the current supplied by each battery and the power dissipated in 1 ohm resistor. Almost all problems are very much similar. Again, this cannot be simplified. We have to think of the Kirchhoff's voltage law. Call it as say A, B, C, D, say E, F. For the consider loop current here I1, and this is I2. For this loop, as I start from here, it is plus 12 minus 0.25 I1, and as I come this way, it is, in this one we have I1, that is 0.2 I1. In the same resistance we have I2, that will be 0.2 I2. Since I am coming from plus to minus, it is minus 12, and I have come to this point or to this point, which is equal to 0. If you simplify this, it works out to be minus 0.45 I1 plus 0.2 I2 is equal to 0. This is the equation 1. Go for the other equation here now. This will be equal to, if you start from here, for example, minus to plus, that is again plus 12. It is minus 0.2 I2 plus 0.2 I1 and minus 1 I2 are that. So, this works out to plus 0.2 I1 minus 1.2 I2 is equal to minus 12, equation 2. Solve these two equations, you will get I1 is equal to 4.8 amperes and I2 is 10.8 amperes. For the circuit shown in the figure, find the current supplied by each battery and the power dissipated in 1 ohm resistor. Power current supplied by the first battery, that is nothing but having a resistance of 0.2 ohm, 0.25 ohm is nothing but I1. That itself is 4.5 amperes. This is 12 volt battery with 0.25 ohm internal resistance. When it comes to this, it is I1 minus I2, that means this is the current in 12 volt battery with 0.2 ohm resistor. I1 being 4.8 minus this is 10.8. So, that comes to 6 amperes, minus 6 amperes. The current is not in the direction of I1, it is not this way, but it is flowing in the opposite direction. So, that means the current will be in the direction of I2 itself, that will be 6 amperes. And then when it comes to the power loss, the power loss in the 1 ohm resistor will be the current flowing through that is nothing but I2, that is 6 square into 1 will give you 36 watts. That is the power consumed by the 1 ohm resistor, that will be this. Six amperes power dissipated in ohm. I2 being 10.8, it is not 6 amperes, it is 10.8 square into 1, that comes to 116.4 amps. Two batteries are connected as shown to a 200 volt supply. Battery A has an EMF of 110 volt and internal resistance of 0.2 ohm. Battery B has an EMF of 100 volts and an internal resistance of 0.25 ohm. Determine the magnitude of the current in each battery and the total current taken by the supply. Two batteries are connected as shown to a 200 volt supply. That means the circuit is this one. This being plus minus, this is 5 ohm, this is plus and this is minus. This is A and this is B. Two batteries are connected as shown to a 200 volt supply. Battery A has an EMF of 110 volts and an internal resistance of 0.2 ohm. The same circuit can be redrawn with reference to other data. This is 5 ohm. This can be simplified as this. this is nothing but A, has a voltage of 110 volts and a resistance of 0.2 ohm. Battery B has a voltage of 100 volts and an internal resistance of 0.25 ohm. Is connected to 200 volt supply. What has been written here with inclusion of the data, it transfers to this. Determine the magnitude of the current in each battery. So what's the current in this, what's the current in this, and what's the total current supplied by the source. In that respect, again you can see here it cannot be simplified. We'll have to go for the loop equations in that respect. Assume one current in this loop I1 and another loop in this. Call this one as say I2. As far as this loop is concerned, if I start from here plus to minus, that's nothing but minus 110. As I go in the direction of the current, it will be 0.2 I1. As I go this way, it is minus 0.25 I1. In this resistance, we have one more current flowing, that's nothing but I2. Since we are moving in the opposite direction, it's obviously 0.25 I1, I2. And then when it comes to this, minus to plus is nothing but plus 100 will give you 0. And the other equation is this for this one. If at all I start from this point, it is this can be simplified also. This will be minus 5 I2. As I go this way, I can go this way also or I can go this way also. Both of them are permitted. However, when I shown I2 as in this direction, I have to follow this loop only. In that respect, plus to minus, it's nothing but minus 100. Then in this resistor, we have two currents, I1 and I2. This will be minus 0.25 I2 and plus 0.25 I1. And when it comes to this point here, it is minus to plus, it is plus 200 equal to 0. As we solve these two equations after simplification, it results into the first equation is 0.45 I1 minus plus 0.25 I2 equal to 10 volt. This is first equation. The second equation is 0.25 I2 minus 5.25 I2 I2 is equal to minus 100. Once it is solved, I1 works out to be minus 11.96 amperes and I2 will be equal to 18.48 amperes. Once these two are obtained, go to the problem. Determine the magnitude of the current in each battery and the total current taken from the supply. What's the magnitude of the current in this? The current flowing through this is nothing but I1. I1 is equal to, it is minus 11.96 amperes. The minus sign indicates that the current is not this way but it's in the opposite direction. Therefore, the 110 volt battery is giving out a current of 11.96 amperes. When it comes to this one, the current in this one can be taken, if I take I2 as reference, current in this 100 volt battery will be equal to I2 minus I1. I2 being 18.48 amperes minus I1 is nothing but is minus of 96, that will be minus of 11.96 will be the total current in this, or the current supplied by that. Since it happens to be a positive one, the current, this is also delivering the current. The current will be in this direction. When it comes to the current delivered by this one is, since this is nothing but I2, therefore it's in the positive direction only. So these are the current supplied. I2 is nothing but current supplied by 200 volts battery is nothing but I2 equal to 18.48 amperes. That's 18.48 minus of minus, that comes to 30.44 amperes. And the current, total current supplied by the supply or current taken from the supply is 18.48. Consider another problem. Find the current in the battery, the current in each branch, and potential difference across A and B in the network shown. The problem can be solved in two different ways. Since these two are in series, they get added up. These two are also in series, they also get added up. These two are in parallel, so you get the parallel combination of that, and that will be in series with this. Once you get that, you can find out what's the value of total current. Once the total current is known, the current in each branch can be calculated. Once we know the current in flowing through this one, you can find out this also. That's one possible way. The other possible way is you can find out the current by going for loop equations also. Before go for that, I'll just go for the usual or the network reduction technique, in which case this can be written as equal to this will be one resistance. This is 5 ohm in parallel with 14 ohm. This will be 3 ohm. This will be 10 volt. The parallel combination of this one can be taken as equal to this is 10 volts, this is 4 ohm, and this will be 5 into 14 divided by 5 plus 14. That comes to 3.68. Now these two gets added up. In that case, finally the network reduces to a single resistance of value 7.68. 4 plus 3.68 comes to this. What will be the current? The current is obviously 10 divided by 7.68 comes to 1.3 ampere. Once I get a value of this one, it's not too difficult. This current being 1.3 amperes, you can find out what's the current here and also current here. Call it as say I1 and this is I2. I1 is obviously, go for the current divider rule, that is 1.3 into the resistance of the opposite branch, that's nothing but 14 divided by the total resistance 5 plus 14. This works out to 0.958 amperes. The current I2 will be equal to, either you can go for this method or you can say 1.3. This current, the total current 1.3 minus this current will give you this current. That's nothing but 0.958 comes to 0.423 or 342 amperes. Once the two currents are known, how to find out the voltage across point A and B. Find the current in the battery, the current in each branch. The current in the battery is obviously 1.3 amperes. Current in the each branch, current in this branch is 0.958 and the current in this branch is 0.342 amperes. And the potential difference across AB. To find out the voltage, you connect a voltmeter here. This voltmeter will record the difference in potential in this path or difference of potential in this path. Both of them should be the same. In that respect, what will be the potential difference here now? If I take it as say A as plus and this as minus, this can be written as equal to VAB. The current here is this way 0.958 and the current here is 0.342 amperes. If I consider only this loop, that means this one, this is VAB, this is 2 ohm, this is 6 ohm, this is 0.342 and this is 0.958 ampere. You can start from any point of your choice. If I start from here, for example, it is minus 0.342 into 6. I am going from minus to plus, it is nothing but plus VAB. Then I am going against this current, therefore it is plus 0.958 into 2 will give you 0. Therefore, VAB works out to be equal to minus 0.136 volt, indicating A is not positive but A is negative. Therefore, B must be positive. That's one thing. Say instead of considering this loop, can we go for the other loop also? Yes. In which case, what will happen? Let us see. This is same. This is VAB. This is 0.958 and this is 0.342. This is 6 ohm and this is 2 ohm. This is 3 ohm. If I start from here, it is minus 0.342 into 6. As I go this way, it is I am going against the current, therefore plus 3 into 0.958. I have taken this one as plus and this one as minus, therefore it is minus VAB equal to 0. If you simplify this, you get a value minus 0.138. VAB will work out to be minus 0.138 volts. One reads 0.1 here. This loop has led to a voltage of 0.136, while this loop has led to a voltage of 0.138. Then why there is a difference in potential? The reason is because all these values are approximate values, this has resulted. If you consider all the decimal places, then the voltage will be the same. If this were to have been rounded off as say 0.14 volt, and this could have also been rounded off to 0.14 volt, both of them results into the same value. What is the difference in potential between the points X and Y in the network shown? This is the network. it's required to find out what's the voltage between these 2 points X and Y. In that respect, now how to solve? Think of this 2 volt battery as it drives a current, this drives a current, so call it as say I1. As the current comes to this point, which path it takes? Should it go this way or should it go this way? In that respect, the current will not take this path, because if at all the current goes this way, from where to return back to the same point? As such, if the current starts from a point, it must return to the same point. In that respect, you will observe there is no path for the current to come back to the same starting point. Therefore, no current flows through this 4 volt battery. Thereby, the current confines itself with this loop. So, this is nothing but I1, it takes this way. In the same way here, this current I2 will confine to this. To find out the voltage between points X and Y, what can be done? Think of connecting a voltmeter between these 2 points. Say V, call it as say Vxy, with the assumption X is positive and Y is negative. Though there is no current here, when a voltmeter is provided here, there is a closed loop, though that will be through this, with the assumption that the resistance offered is very high or the current is flowing through this. So, with that we will be coming back to this point. With that in mind, now what is the I1? I1 is nothing but this voltmeter will record the voltage drop across this one, drop across this, or voltage source of this one plus this one. In that respect, what's the drop here now? Take it as I1. What is the current here? It is 2 divided by 2 plus 3, that comes to 0.4 amperes. And similarly, when it comes to I2, it will be equal to 4 divided by, these 2 resistances are in series, that comes to this 0.5 amperes. With that, as I start from here, I am going against the current, therefore it is plus 3 into I1. I1 is nothing but 0.4. As I go this way, minus to plus, it is nothing but plus 4. And when I am coming this way, the current is coming this way, it is minus 5 into, the current is nothing but 0.5. And as I move this way, minus to plus, it is nothing but plus Vxy equal to 0. If you simplify this, Vxy works out to minus 3.7 volt, indicating that X is not positive with respect to Y, but Y is positive with respect to X. I will stop here. I will continue with some more problems in the next class, and then go for the electromagnetism or electromagnetic induction also. Thank you.